Okay, so what we're going to talk about today is we're going to start talking about inverse trig functions, okay? We've spent a lot of time talking about finding inverses of a lot of different types of functions. We know that if I have a point, xy, what's the inverse of that point? Yx, great. So we know how to find the inverse of a point, no problem, right? So what if I wanted the inverse of y equals 2x plus 3? Good, we're going to switch the x and y. And generally, we then do what? Solve for y. How? Yep. Subtract the 3 and then divide by 2. How do we write it? Do I write y? What's the notation? Not y, not x, f to the negative 1 of x, okay? So there's your inverse notation, right? So we're going to see this notation keep popping up. So we know how to find inverses. This is nothing new. So what we're going to do now is we're going to look at how we find the inverses of our trig functions. And we're going to look at the graphs of these inverse functions as well, okay? So that's just a little reminder. All right, so we have to have a very basic understanding. We know how to find inverses. We know that we're going to take our domain and our range and flip-flop them. So we're just going to have to kind of do it in a little bit of a different way, because with our trig functions, we're going to see something strange that happens graphically, and we're going to have to adjust for that, okay? So as you can see, if a function's inverse is a function, we know that we can determine if a function's inverse is a function by telling if they're one-to-one. How do we determine if a function is one-to-one? It's got to pass what tests? Vertical and the horizontal, right? Horizontal line test, it has to pass it. So if a function is one-to-one, then its inverse is also a function. So I'm going to say that again, okay? If a function is one-to-one, its inverse is also a function. All right? So we're going to take a look at sine, cosine, and tangent, and we're going to determine whether or not they're one-to-one. Okay? So I'm going to insert a graph page, and let's look at sine to start. I'm going to put it on a nice pretty interval, negative 2 pi to 2 pi. Okay. Does it pass the vertical line test? Yeah, absolutely. Does it pass the horizontal? No. So what does that tell me about sine? It's not one-to-one. So what does that mean? What does that mean? Its inverse isn't a function. Okay, its inverse isn't a function. Good. Okay, so it's not one-to-one, so we know the inverse of sine can't be a function. So let's look at cosine. One-to-one? No, why? What's it fail? Horizontal line test. So that means what? Its inverse is not a function. Awesome. Okay, one more. Let's use tangent this time. Again, I'm going to put it on a nice pretty interval for us. One-to-one? Why? What's it fail? Fails the horizontal, right? So what does that tell us about the tangent function? The inverse isn't a function. Okay, so not a single one of these is one-to-one. How can we tell? They all fail the horizontal line test. Okay. Okay, so what does that imply about the inverses of these functions? They're not what? Right. So the inverses of these functions are not functions. Okay, so the inverses of these functions are not functions. Okay, so what we're going to do is we're going to learn how to restrict the domain of sine, cosine, and tangent so that the function that we're looking at is one-to-one. So we're going to learn how to restrict the domain. What does restrict mean? Limit it. Yeah, we're going to put limits on it, right? We only want a part of my function. The part that we want is going to be one-to-one. Okay, so we're going to learn how to restrict those domains. So I'm going to go back to my sine graph, my sine curve. Here's my sine curve. And I want to restrict the domain so that it includes the first quadrant. Okay, the first quadrant is from what to what? 0 to 90, which is, I've been gone for 3 days, guys. Come on. Pi over 2, thank you. All right, so 0 to pi over 2 is the first quadrant, right? So we know this right here is 0. What's the maximum? This is a sine curve. Where is sine equal to 1? 90, which is what in radians? Pi over 2. Okay, so 90 degrees or pi over 2. You guys are killing me. When do I go back to 0? At pi, or 180. Okay. All right, when do we hit our minimum? 270, which is what in radians? No. 3 pi over 2. Expect a quiz coming up on this material again, guys, because you need to know it. And when do we hit 0 again? 2 pi, which is 360. Ouch. That was painful. Okay, so I want to restrict the domain so that it includes this first quadrant. Here is my first quadrant. Got it? I said include, right? So that means everything above this green shaded arrow must be included in my restriction. So is that all I need? Can I keep going to the right? Can I keep going this way? No, why? Yeah, because then it's not one-to-one, right? It doesn't pass that horizontal line test. Which way can I go? Yeah, down to my negative values, right? So tell me when to stop. Good, right there, right? Where the minimum is. Who can tell me what that value is? Awesome, negative 90. What is that in radians, please? Negative pi over 2, thank you. Okay, so this green portion, right, is that portion one-to-one? Absolutely, passes the horizontal and the vertical line test. Agreed? Okay, so my restricted domain will be negative pi over 2 to pi over 2, or negative 90 to 90. Okay? If I restrict that domain, then the inverse is a function, okay, which is what will allow us to graph the inverse. So we have to be able to restrict that domain in order to graph the inverse of this function. Yeah. Okay. We want to include the first quadrant. Okay, 0 to 90. We want to include the first quadrant. We want to keep it so that it's one-to-one. As soon as it's no longer one-to-one, you can't graph it. It's not, the function's inverse is no longer a function. Okay. So these are my restricted. This is my restricted domain. What do you think? Not bad, right? I'm waiting. Are you ready? Okay. All right, so the question asked, give a restriction to the domain, so that restriction is negative 90 to 90 or negative pi over 2 to pi over 2. That would include the first quadrant. Now, we're going to do the same thing for cosine and tangent, okay? So I'm going to go back to my cosine graph. Oops. I'm going to make it so it's a nice, pretty interval, so it's easier for us to look at, negative 2 pi to 2 pi. You are going to figure out what the restriction is, all right? So I'm going to pause here, give you a minute to figure out a restriction that would include the first quadrant, okay? Then I want you to think about it. We know it's 0. Where it hits 0 again, right? our maxes, our mins, and our zeros are where our axes are, 0, 90, 180, 270, 360. Okay, so that's how you're breaking this up. All right, so I'm going to pause here. You guys figure out the Okay, who's got it for me? Yes, it matters. 0 to pi, good. 0 to pi, right? So from 0, this is my first quadrant. I want to include it. I can't go this way because then it's no longer 1 to 1. It's not going to pass the horizontal line test. So I'm going to keep going this way until I hit the minimum, right? And this is at pi. So 0 to pi is my restricted domain for cosine. Okay? We want it to include the first quadrant. Okay, so 0 to pi is my restricted domain for cosine. We got one more to go. We're going to look at tangent. I'm going to pause here for a few minutes, find my restriction for tangent. Okay, who's got it for me? Anybody? Say it again. Awesome. Negative pi over 2 to pi over 2. Now, who wants to fill in the missing piece here that I'm thinking about? No? What am I concerned about? I don't include negative pi over 2 to pi over 2. Why? Why are these values not included? Why don't I include them, though? There's a reason. There's a very specific reason I do not include those values. Say it again. Yeah. Okay. Does tangent exist at negative pi over 2 and pi over 2? No. Okay. That's where cosine is equal to 0. So tangent is undefined at negative pi over 2 and pi over 2. That's where we get those vertical asymptotes. Okay. So we can't include them because they don't exist here. Remember that? Okay? So the restricted domain is from negative pi over 2 to pi over 2, not included. Good. Okay, so now that we have restricted domains of sine, cosine, and tangent, what we're able to do is we're now able to graph the inverses of these, okay? We know that if we have the point AB, the inverse is simply BA, okay? So we're switching those values. Now we're going to do it graphically just to kind of for the sake of time. So what I want you to do is you're going to insert graph page, please. Okay. First of all, we're going to start with this sine. So we're going to actually graph sine inverse. Hit your trig key. Where do you see sine inverse? Yeah, right below sine. There it is. Okay. Hit enter. Pardon me. Put an X and hit enter. Notice it's just a little piece, right? Why is it just a little piece? Yeah, it was the only part of it that was 1 to 1, right? We had to restrict that domain to make it work for us, okay? So here's my original function, sine. Do you see how it came from it? Why is it the inverse? What is the inverse graphically? Don't say opposite. I hate that word. It's the inverse, but graphically, what do we do to get the inverse? Don't say flip it. Give me math words. Good. Reflect over the line y equals x. Okay? So we're reflecting over the line y equals x. Is that a reflection over the red line? Yeah, absolutely. Okay? Absolutely. That's a reflection over the line y equals x. All right? So it's just that little piece that we restricted the domain for. All right? So let's enter another graph page. Let's do it for cosine now. Y equals x. So we're doing cosine inverse this time. Is it going to be a big piece or a little piece? Little piece. Okay. I'm going to zoom trig it just to make it look better. All right, so there it is. Looks a little bit different, right? Should. Here's what it's coming from. Now, when I graph the line y equals x, where is it going to go? Good, right where they intersect. Okay, great. So again, it's just a reflection over the line y equals x. We're flipping our domain in our range. One more. Tangent. This one's going to be cool looking. I like this one. Whoop. Why is it sideways? It's reflected over the line y equals x. Okay. That's not a nice thing to say. Okay, so there it is. So which one am I using? Yeah, I'm just using this one, right? This is the only one I'm using. So this is the one that's being reflected over the line y equals x. Okay. And there it is. Okay? So generally, when we're talking about inverses, the way you'll be tested on inverses is it'll be a multiple choice question, and they will ask which one is the inverse of cosine. And you put it in your calculator, you graph it, and you circle the right one. Can you handle that? Well, you have to know what the graph looks like. So you have to be able to push a button in your calculator, bring up the graph, and say, oh, it's that one. Good? Okay, excellent. So let's get into the algebra of it. Okay? Now, all that we're doing is we're finding the values. This should be the easiest, okay? You're going to click on this right-hand side. You're going to hit Menu, Actions, Text. We're going to put in text boxes, okay? What is sine at negative pi over 2? This is negative 90. Negative pi over 2 is negative 90. But what is sine of negative pi over 2 equal to? In terms of what's it equal to? Neither. Negative 1. Thank you. Why? Right? Here's sine. Agreed? I go back this way. Looks like this. Agreed? Here's negative 90. What's it equal to? Negative 1. Okay. All right. What about at 0? 0. You're hitting enter to make them stay, by the way. And pi over 2? 1. Okay, listen. Notice all these values are 1, 0, negative 1. These are your angles, okay? These are angles, 90 degrees, negative 90 degrees, 0 degrees, okay? These angles are going inside the function. Angles go inside, okay? They don't equal another angle. Got it? They equal a value, 1, negative 1, 0. Okie dokie? This is nothing new. We have been doing this for like a month now. Okay. Uh-huh. All right, so what do we do with points when we find the inverse? We switch them. We switch the domain and the range, okay? So on the next page, you're going to fill it in. So x is now going to be negative 1, and sine inverse of x is going to be negative pi over 2. So you're simply flipping these around, okay? Flip-flopping them. I'm going to leave my page up so that you can fill in the chart on the next page. Got it? So I'll pause here and let you do that. Okay, so x was negative 1, negative pi over 2, 0, 0, 1, pi over 2. Are we okay with that? So you're just flip-flopping points. No. Okay. So what this means is if I were to look at this, right, this is what it's going to look like. So I could say sine inverse of negative 1 is going to equal what? Yeah, negative pi over 2. Okay. sine inverse of 0 is going to equal 0. Sine inverse of 1 is going to be pi over 2. Okay? So what I've done is when we normally have y equals sine of x, when you take the inverse, we know we have to do what with the x and y? Flip-flop them. But we have to make sure we use the right notation, sine inverse of y. So what I've done is I've switched them, okay? So to find the angle, we use the inverse, okay? This is the angle, all right? This is the angle. What it's equal to is the angle. So to find the angle, we use the inverse. Repeat it. To find the angle, we use the inverse. Do it again. To find the angle, we use the inverse. So if I want to know what the angle is, I'm given the value. I want to know the angle. I got to use the inverse. Okay? And the angle should make sense, guys. You shouldn't have an angle that's 0.75, right? Angles are generally larger. So, what? Yeah, you've done this in 9th grade. To find the angle, you use the inverse. This is exactly what we're doing. This is review from 9th grade. How many of you remember it? One of you. Yes. Okay, so this is review. We just didn't do it using radians then. We were using all degrees, but this is nothing new. Okay, so we already did this, didn't we? Yeah. Okay, so here's our first equation. Sine theta equals negative 1/3. I am looking for what? What do I want to solve for? What do I want to solve for? Theta. What does theta represent? An angle. Awesome. Okay. All right? Yeah. Okay. So, what always goes inside a trig function? An angle. Say it again. What goes inside a trig function? An angle. Okay. What goes inside an inverse trig function? Not an angle. Okay. What it's equal to. So what goes inside the trig function is an angle. I'm looking for the angle. To find the angle, I use the inverse. Say it again. To find the angle, I use the, am I being repetitive enough? There's a point, okay? I have to use the inverse to find theta. Now here's my issue. I don't want to use the negative. See how it's equal to a negative 1/3? I don't want the negative. What I want to do is I want to find the reference angle. Where does my reference angle lie? Where do I find reference angles? What quadrant? Quadrant 1, right. Reference angle is an acute angle, right? Between 0 and 90. So I want the reference angle. The reason being is with trig functions, trig equations, 9 times out of 10, there's more than one solution. So can we just have one? No. So we have to find the reference angle so we could find all of the solutions using our all students take calculus, right? Because we know sine, we're looking at a negative, right? Or a sine negative. Yeah. How many solutions am I going to have? 2. I have 2 places where sine is going to be equal to negative 1/3. And we're going to look at that graphically next class and learn how to do it algebraically. But we're out of time. So pages 2 and 3 for homework tonight. We'll pick up here tomorrow.